Okay, I've got the top of the hour on my clock, so we're going to get started. Welcome, everyone. Hope you're all having a good Tuesday so far. I'd like to thank you for taking some time out of your day to join us for this webinar on climate-resistant infrastructure for extreme weather events. So when extreme weather events occur, communities are often left to grapple with the devastating effects. An increase in extreme weather patterns coupled with aging or inadequate infrastructure amplifies the often dangerous and costly damage that ensues, especially for vulnerable communities in low-lying areas. In today's webinar, we're going to discuss how to incorporate GeoWeb geocells into projects to create climate-resistant infrastructure in load support, slope stabilization, channel protection, and retaining wall applications. So a lot of stuff today. So the discussion is going to include solutions for an array of industries, including energy, transportation, and stormwater management. Project case studies are going to show how this advanced geosynthetic technology can be used for rebuilding storm-ravaged roads, repairing and stabilizing channel embankments, and preventing flooding after extreme weather events. So I'm your host, Sam Justice, and I'm a licensed professional engineer in the state of Wisconsin with degrees in civil and geotechnical engineering. I'm one of the engineers here at Presto Geosystems. We manufacture erosion control, stormwater management, and porous pavement products, all of which are made in the upper Midwest of the US. And through an extensive national and international distribution network, we offer technical and site support, as well as a free project design evaluation from our in-house design engineering team. It's me. We'll talk about that at the end. So here are some things that I hope you get out of today's presentation. Understand how our products can provide permanent solutions in building roads as well as alongside roadways. Understand how geocells can work in challenging soil environments. Learn about the different applications where geocells can be used, and learn how they can help manage stormwater and stabilize slopes along roadways and other areas to help mitigate flooding. And basically, we wanted to show you how the geocells, the GeoWeb geocells, can prolong your project lifetime. So infrastructure development for highways and road corridors face many challenges when it comes to project design and construction. So building with asphalt or concrete roadways over soft soils typically requires a really thick base that can be damaged during during extreme storm events, where that stormwater has that potential to wash away that base. And really, in a lot of different infrastructure applications, you need to over-design for those extreme weather events that you don't necessarily think about in your everyday, day-to-day use of those pieces of infrastructure. So everybody is going to be muted during this webinar. You're not going to be able to talk or anything, but if you do have questions, please feel free to type them in your questions tab on your GoToWebinar menu. I'll see those, and at the end of the presentation, I'm going to have a bit of a Q&A session where I go through some of those questions and try and answer those, clarify things if there's any confusion, that sort of thing. Okay, so first a little bit of background on who Presto Geosystems is. So we worked with the U.S. Army Corps of Engineers to develop geocell technology in the late 1970s and have been innovating in this market ever since. Our products have been used in over 200 countries and in every state in the United States. And we go beyond simply providing a product. We're here to help you provide a complete stabilization solution. So we do operate in 3 product areas. We offer different solutions. So soil stabilization using our GeoWeb geocells. And those can be used for load support, slope and channel protection, and then constructing green retaining walls. This is going to be our focus for today. But we also offer porous pavements, where we have both a vegetated and a stone option, and then also lightweight reusable construction mats. So if you do have questions about either of those product categories, more than happy to talk about with them offline on a one-to-one basis. But today we're focusing on the GeoWeb 3D soil stabilization system. Okay, so let's cover some general information about the GeoWeb geocells For those of you who might not be familiar with this type of product, like I said, we've been doing this for about 40 years, but it still is a bit niche, and maybe you haven't heard of it before. So the GeoWeb system is our version of GeoCell technology, and it consists of two main attributes. The first is going to be the cell or the container size. So the cells come in 3 diameters, small, medium, and large, and then have cell heights of 3, 4, 6, 8, and 12 inches, so 5 different depths to choose from. The dimensions that you're going to choose for your GeoWeb cell are going to be dependent on your project details, whether you have specific vehicle loading requirements, what your slope dimensions look like, that sort of thing. And we here at Presto Geosystems can help you determine which one is going to be the most appropriate for your specific job. Another thing I want to point out is going to be the ultrasonically welded seam, and that's going to be where all of the connecting points are. And that's going to be really important to the function of a geocell in general. The stronger the seam strength, the better the performance of the geocell. So a strong seam allows for heavier infill material, steeper and taller slopes, and better overall lifetime performance. The GeoWeb system is produced using high-quality virgin high-density polyethylene, HDPE. And so this produces consistently strong welds at each of these cell junctions. But it also maintains semi-rigid ductile properties within the cell walls. And then also things like high stress crack resistance, overall toughness, and long-term durability in extreme environmental conditions. So it's not necessarily important that you remember that it's semi-ductile, but it is important to remember that we've developed the GeoWeb system in a very specific way using the HDPE resin because it is going to provide the best performance in the field for the largest variety of projects. So the GeoWeb system doesn't use things like fillers or exotic polymer alloy blends that you might hear about in other types of geocells. And the reason that we don't do that is because using fillers or alloys might strengthen a single property within the GeoWeb or within the geocell system, but it does it at the expense of other properties. So you could potentially increase your weld strength, but you would ultimately reduce your environmental stress crack resistance or your wall stiffness. And those are things that you don't necessarily want. You need a good balance between all of those different properties. So to avoid things like weld failures or the damaging effects of differential settlement on an extremely stiff product, uniformity in performance across all the elements of a geocell system is going to be much more important than focusing on a single property alone. So you'll probably hear me say that a lot, especially at the beginning here. Uniformity in the geocell and in the geocell performance is going to be kind of the key takeaway that I want you to have here. Okay, so I said there were 2 main attributes to a geocell system. The first was the actual geocell material itself. The second main attribute is going to be the infill material. So it's going to be what you put in those containers. So an important benefit of the GeoWeb system is that even a low quality aggregate, sand, or even salvaged materials such as recycled concrete or asphalt can be used to infill the cells. So using salvaged aggregate or sand can save a significant amount of money on things like material and hauling costs. Excuse me. And you can also do things like eliminate the fines within your material because the cells themselves of the GeoWeb panels provide the confinement and aid in compaction of those cohesionless materials. So you don't need to have a cohesive material to get that compaction. The GeoWeb cells are doing that work for you. And if you do eliminate those fines, you can significantly improve the drainage of the system and let water flow freely, preventing poor pressure buildup and preventing global failure of the system due to that hydrostatic buildup. So definitely a benefit. And the ability to use those sands and those low quality aggregates really sets the 3D GeoWeb system apart from things like planar geogrids or geotextiles. So these products require the use of really high quality materials that have extremely high friction angles to achieve that optimal performance with the 2D system. But with the 3D GeoWeb system, using that low friction angle material is going to be just fine. The GeoWeb panels can achieve their full potential even when using poor quality materials. So definitely a huge cost savings there. So the system components to the GeoWeb system, these are going to be the add-ons to the GeoWeb cells themselves. And so these are all going to be all of the supporting pieces that help the GeoWeb system protect your project site and again assure that uniform performance. So these are going to help provide that uniform performance across the whole site area. You're going to avoid, differential settlement, damaging effects of, different materials, that sort of thing. So this is again uniformity, our keyword at the moment. So thinking back a few slides, I said the GeoWeb panels do come in discrete sections. And the average size of a section is going to be around 250 square feet. Your project is most likely going to be bigger than that, so multiple panels are required. So we have what's called the Atra key. This is going to be that first component of a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers your entire project site. So it allows for faster installation of the GeoWeb panels and is going to last the lifetime of the project, ensuring that your road or your slope or your wall is going to be protected and that the GeoWeb system isn't going to fail under anticipated loads. And the specific engineering values of the Atra key are going to ensure that the system holds up to loading over time without the corrosion seen in metal staples or the failure of underperforming, weak plastic cable tie systems. And we do have a specification sheet for the GeoWeb system, and it calls out this specific type of material. It has specific engineering values for this patented connector, so that you know that you are getting the right material to help hold the GeoWeb system in place. And I did also briefly want to mention that we do offer a specialized version of the Atra key. It's the Atra wall key. It's designed specifically for connecting GeoWeb retaining wall sections. So we're going to get to talking about retaining walls in a moment, but this is just something to keep in mind. So the Atra wall key is the only GeoCell connector available anywhere that's designed for the use in exposed wall face applications. So it's formulated to withstand environmental weathering and ultraviolet radiation. And the Atra wall key is not going to corrode or degrade over time like those zip ties or those metal staples. Even in really harsh environmental conditions, it can be submerged in salt water, and that's not going to cause any degradation either. So pretty much anything that you throw at it, it's going to be good. And securing sections with the Atra wall key is going to be a lot faster than using staples or zip ties. Requires no specialized or electrical tools, and it's easy for a single person to do single turn, click it in place, ready to go. So it's this, the Atra wall key, and then the Atra key are both just sort of specialized components that help with that uniform system that I want to make sure you guys are aware of. So next we can take a closer look at the anchorage options. If the GeoWeb panels are laid completely flat, anchorage is usually not necessary because gravity is doing all the work to hold it in place. However, if you do place these on a slope and that angle starts increasing, you got the driving force of the infill material exceeding the resisting frictional force of your slope. So overcoming all of that, it wants to slide to the bottom of your slope. Want to avoid that with some sort of anchoring option. So for shallow slopes, and sort of a general rule of thumb is if it's shallower than a 2 horizontal to 1 vertical, around 26 degrees, if it's shallower than that, you can use stake anchorage. And so we have 2 options for that, one of which is a standard steel rebar. and one that's made of pure high-density polyethylene. That's what's pictured here. So HDPE might be good, again, if you are in that saltwater environment, if you're perhaps along a coastline. Metal would corrode in that salt water, so you might want to choose HDPE stake. So just an option. But they are easy, fast to install, nothing too unusual about stake anchorage. But the other one that we want to talk about that maybe people aren't as familiar with is going to be a tendon option. And so this is for steep slopes. So if you're getting steeper than that 26-degree slope, or if you are over a surface that you can't puncture with a stake. So if you have a geomembrane liner over a sediment pond, you don't want to puncture through that liner, defeats the purpose. So you need to be able to suspend the GeoWeb system over that liner without damaging it. And so that's where we would recommend a tendon anchorage system. So these are polyester tendons that are run through the GeoWeb panels. You can see them in the photo there. And then you use our Atra tendon clips, which are load transfer devices. Basically, they take the load from the soil to the tendons to the GeoWeb panels and then up to the crest of the slope. So just something to keep in mind. Again, we can talk about this in more detail if you are curious how it works. But it is something that, again, is specifically designed for the GeoWeb system, helps with that uniform performance, and is going to be something that lasts the lifetime of your project, as opposed to something that's going to degrade or is going to break down over time due to environmental conditions. Okay, so just something I kind of want to point out goes in line with everything I've been sort of talking about recently here, about that uniform performance and how a geocell performs. And so it is critical that both what we call the factory welded junctions, so these are the internal seams that I pointed out a couple slides ago, and then also the field joined junctions. So those are the Atra keys and the Atra wall keys that I pointed out as well. And so both of those types of junctions perform at a level that's commensurate with the cell wall. So you want the junction, you want those seams and those keys to be as strong as the GeoWeb panel itself. Otherwise, you're just introducing a point of failure. So the three primary elements of that GeoCell system, the cell walls, the internal junctions, and the mechanical junctions, all must perform uniformly as a complete system. So again, as I sort of mentioned before, an incremental improvement in one characteristic, such as wall stiffness, is only going to be valuable if there's a complementary improvement in the other components of the system. So as stiff as you make the cell wall, you have to make the junctions and the field connectors the same stiffness. Otherwise, now you have a point of failure, and that increased wall stiffness just doesn't mean anything because it's going to fail at the junction before it would fail in the cell wall. So the GeoWeb system is manufactured using that virgin HDPE that I mentioned. We've been doing this for 40 years. We really have stood, the test of time. We haven't seen any project failures due to, failure of our material. So, at a typical site, the GeoWeb system is going to retain its durability for, we say, greater than 50 years. That's more than we've been in business, with lab testing indicating more than 150 years without degradation, and that's based on that HDPE material. Even at full exposure to the elements, that includes UV radiation, that includes saline environments, high pH soils, anything like that. So we stand behind our numbers so that you can deliver certainty in the solution as you build with materials that you can trust. So just our little pitch for making sure that you choose a GeoCell that's really going to do the work that you want and expect it to, and not choose something made of inferior material just because maybe it's a little bit cheaper. Okay, so with that background about what a GeoCell is, how the system works, that sort of thing, we're going to move on to discuss some of the soil stabilization capabilities of the GeoWeb system. And it's going to be for a number of different applications. We're going to start with load support. So this is where you're driving vehicles over the top of the GeoWeb panels. So Presto Geosystems does offer solutions for many different types of road and highway applications. And this includes load support for unpaved roads where you have a gravel surface, road shoulders, and base stabilization underneath paved roads. And then stormwater control is also possible with the GeoWeb system through things like roadside ditches, drainage channels, culvert outfalls, and having that aggregate system be a little more porous to allow some pervious pavement aspects as well. So the purpose of cellular confinement of the GeoWeb system is pretty simple. It's meant to stabilize the movement of unstable soils, both horizontally and vertically. The weaker the subgrade conditions, the more practical it is to insert the GeoWeb system into your design. So it's an engineered system integrating a couple different types of geosynthetics with the best method of confinement and subgrade stress reduction in the industry. And so today's focus is going to be on a lot of different types of how the GeoWeb system works. But if you do have specific questions on roadway infrastructure, such as intermodal yards, railroad ballast reinforcement, things like that, feel free to reach out. We have extensive knowledge in that as well. So if there's something specific that I don't get to today, this is a really general overview. Please feel free to sort of drill down and get into specifics. We would love to talk to you about it. Okay, so the GeoWeb system works like this. When a vertical load is applied, the active earth pressures in the loaded cell pushes back against the passive earth pressures in the adjacent cell to create a stable system. So basically, being confined, the soil responds passively. The infill is limited in its movement, as represented by those yellow arrows in the diagram. And then the cells adjacent to that middle cell, that loaded one, provide that passive resistance with the red arrows, so sort of going back against each other. And then the load is also dispersed over a greater area in the lower layers as each cell helps support the one around it. The GeoWeb cell walls also transfer what we call hoop stress. And so this is important in keeping the system intact and creates the mattress effect. So the hoop stress are going to be those blue arrows that go along the cell walls. So the strength of the seams around each cell, and then also the material properties of the individual strips, and the connection methods, so those three things I talked about, the cell walls, the internal junctions, and the field connectors, all work together to determine how the GeoCell system can work to improve your load-bearing capacity. So in a load support scenario, vertical deformation can really only occur when there's either compression or compaction of the soils or through lateral movement of the soil. So by spreading out the load in a classic granular fill approach, one can reduce the compaction of near surface soils, but only with cellular confinement can one ensure that there's no lateral shifting. So there's not going to be any ruts, you're not going to get potholes, you're not going to get those sunken drive lanes. The mattress effect of the GeoWeb system reduces the stress reaching your subgrade. And so here you can see how the stresses on the subgrade of the unsupported grade on the left, and then with the GeoWeb reinforcement on the right. And so you can see how there's a complete elimination of the highest stresses, the red and the orange, at the surface of the system when there's GeoWeb reinforcement. So the stresses are reduced and then they're distributed over a wider area. So again, that's that mattress effect. So it's going to reduce your stress reaching the subgrade, lead to a significant decrease in deflection and rutting. And again, by eliminating that lateral particle movement, the soil isn't getting pushed to the side because of vehicle tires. The GeoWeb system can stabilize the surface, eliminating the need for constant maintenance. You're not having to go back and grade out, refill in the ruts, that sort of thing. It's just going to be a good, smooth surface for the lifetime of the project. So here we can see an impressive load support benefit. So this is going to be an 80,000 pound loaded dump truck. So this is standard AASHTO H20 loading parameters. And this is on a partially filled GeoWeb panel. So you can see how the cells push back against each other to support the load, and that only the adjacent cells need to be filled for support. So this is a great benefit to using the GeoWeb system, that you don't have to have every single cell completely filled before the road is actually usable. So you can reduce your construction time, your materials, that sort of thing. You can actually use the road as you're building it as an access road to new locations. So the GeoWeb system is often compared to 2D geogrids, and they do start with a similar concept. However, due to the 3D nature of the GeoWeb system, it's got that defined depth. The integrated infill plus geosynthetic system acts as a composite layer where the lateral earth pressures are mobilized and transferred across a three-dimensional network of integrated cells. So basically, all we're saying is by having that depth and that confinement of the material, you're actually creating a layer that's going to help reduce that stress. Whereas with a 2D geogrid, you're inserting the geogrid and then you have to find your confinement and your strength through other means. So we're just sort of making that into one thing with the GeoWeb system. And so this is where it can be really beneficial to be able to use the GeoWeb system, in that you can use those low quality aggregates. You can use sand, you can use salvaged material from excavations, you can use recycled concrete or asphalt, things like that. So you don't have to bring in expensive engineered aggregate or things that the geogrids require. You don't need with the GeoWeb system. So another thing I kind of want to point out is that geogrids do very little to stabilize the surface. So what I mentioned just 1 or 2 slides ago, with the lateral confinement within the GeoWeb panels, you're not going to get those ruts. You're not going to see the lateral shifting of your aggregate or your soil particles that you need to constantly come back and fix. Geogrids don't do that. They don't protect against that. So you're going to have that constant surface maintenance with a geogrid. You're not going to with a GeoWeb. So just something to keep in mind. And sort of continuing the theme of unpaved gravel surface roads, using a washed or a clear stone can be used in the GeoWeb system, allowing you to build stable and permeable low impact development access roads. So site access, either temporary or permanent, are pretty common applications with the GeoWeb system. So if you're going through environmentally sensitive areas, if you're going through wetlands, if you're going along coastlines or shorelines, that sort of thing, where you really need to make sure you're not impacting the flow of water in any way, having a permeable aggregate road like this is a great solution. And as I mentioned, heavy loaded vehicles can still drive on the GeoWeb system, even in sort of sensitive environments like that. Normally you're not going to be driving a dump truck through a wetland. It's just too soft and mucky. With a GeoWeb stabilized road, you have that ability, you have that option. So definitely something that to keep in mind if you know that you're going to be encountering those types of environments. And so with the GeoWeb panels, like I said, you can bridge those soft, wet areas of the ground with little to no disturbance. And saturated soils usually don't support any type of vehicles, let alone heavy vehicles. And you're really doing damage to the environment when you do try and drive through them when they're flooded, like the inset photo there. And so things like adding a woven geotextile underneath the GeoWeb panels can help add additional strength to the system, and they're not going to get clogged by your subgrade materials. So it's still allowing for that free water movement. And having that clear stone, again, without those fines, allows water movement through the system in a way that a concrete or an asphalt road wouldn't allow. So this is going to be our first case study. So this was a project for Duke Energy down in Florida. So they needed to install new transmission towers through wetlands. And that was because Hurricane Michael had come through this area. And the high winds and all of the debris that gets picked up during a hurricane actually had demolished over 100 transmission towers through this area, all of which had to be restored over this extremely soft subgrade. You can see how easily even just boot prints are being formed in this soil. So you can imagine trying to drive construction vehicles was a nightmare. So the GeoWeb system was used for access and maintenance roads, as well as actually creating maintenance pads around the base of each of the towers. So the saturated sand in this area really couldn't support any type of vehicle load. So an enhanced woven geotextile was placed over the subgrade. And so that added just an additional strength layer to the system. It wouldn't get clogged by the sand or the flowing water. And it was able to also hold the stone of the infill material in the GeoWeb panels without letting it sort of sink down into the wetlands muck underneath it. So it provided a little bit of confinement as well. And so the GeoWeb panels were actually filled with a really low quality aggregate that was locally sourced. And so this was made it a little easier for these remote locations through these wetlands to have a locally sourced stone rather than having to find an engineered stone manufacturer and truck it in from long distances. And so once the panels are filled in, both wheeled and tracked equipment can easily drive over these systems. And again, even if you do have that sand, which usually sort of is a bit more of a challenge for tracked equipment, not an issue with the GeoWeb system. And so you can see how the GeoWeb panels sort of act as their own access road. You just sort of keep filling the cells in front of you and you can get farther along down the road. So no need for additional temporary roads, so you're having less impact on the surrounding environment, which is always a benefit when you're in these sensitive areas. Okay, so that was sort of an overview of load support. Another big one that the GeoWeb system can do is going to be on embankment stabilization. And so many times slopes and embankments need to be stabilized after or in conjunction with road and highway construction. And they're going to be sort of the vulnerable point during extreme weather events, especially if you have like a really high rainfall event that you weren't anticipating. That's potentially where you would see slumping of material or sort of like erosion where you're then covering your road. You have to take your road down, that sort of thing to fix. So we want to help prevent that. So the GeoWeb system for slopes, it can be filled with a couple different materials depending on your project needs. Topsoil with vegetation is probably the most common, but sometimes vegetation is not appropriate. Maybe if you're not in the right environment, that sort of thing. So you could also fill in with stone or even concrete. That's what you're looking for. Okay, so I just want to do a quick simplified diagram showing how the different system components interact with the GeoWeb panels to form a complete system. So the first thing to go down is a geosynthetic underlayer if required. So typically this is a GeoGrid or a non-woven geotextile, something like that. And this could also be something like a geomembrane liner if that's necessary for your project site. So whatever might be in place here, you can do. You also might not need it. That's going to be a project specific sort of thing. We can help you determine if one is required or not. And then you're going to put the GeoWeb panels directly on top of either that geosynthetic or on your native ground. And then take that all the way from the toe of the slope up to the crest. And then you're going to have it in some sort of crest anchorage trench. Then you're going to have to fill it in, topsoil, stone, concrete, and have some sort of anchorage system. So we talked about this way back at the beginning. You can either use stakes if you have a really shallow slope, again, less than 26 degrees is our general rule of thumb. And then if you do have a steeper slope or you have that geomembrane liner, you would do a tendon system and you'd have crest anchorage. That's typically something like a dead man pipe or earth anchors or rock anchors something along those lines. These are things that we can help you determine what's going to be most appropriate for your project site and what type of anchorage and how much is necessary. There is no one right answer. It's all very project dependent, and I know that that's sometimes a bit of a rough answer because it doesn't really give you what you need, but I just want to say you can always reach out to us. And we do offer those free project design evaluations. I'll talk about more of those at the end of the presentation to help you determine what is going to be the most appropriate recommendation for your site. Okay, so the GeoWeb system, especially when it's filled in with topsoil, but on a slope in general, kind of works in a way to prevent significant movement of the soil by confining it within each of those individual cells. And so by separating the soil into smaller segments, the system resists mobilization of the entire slope face due to hydraulic load. So you're not going to get, mass movement of the soil due to water flow. And so it's important to reiterate that the proper installation of the GeoWeb system includes embedding the GeoWeb panels into the crest of the slope. And this prevents water from flowing underneath the GeoWeb panels and undermining the system. So you're not going to see rills or gullies forming underneath the panels that could lead to failure. And a system that provides a way to fully vegetate slope surfaces that otherwise might not be able to support sustainable plant life. It also increases the overall slope stability by interlocking with the vegetative root zone. You could also go with that stone or concrete infill, like I mentioned, if your slope is in a really arid environment, you don't think vegetation is going to grow. Choosing stone might be the right option. Vegetated slopes probably are the most common. They're going to result in the most attractive slopes. Little to no maintenance. Once everything's in place, you kind of just let it grow and place it and forget it, which is nice. So this was a vegetated road embankment. It was actually over some unstable soil in an active gold mine up in northern Canada. And so the access road was going to be built above the slope, kind of where the equipment is right now. And so the slope had to be stable enough to support live traffic loads, and then not allow, constant erosion of the slope that could potentially undermine the road. So using the GeoWeb system helps stabilize and support the slope. You can build the road right on top of it and you're good to go. So this was another view of that same area. But you can see how space constraints are sometimes an issue, either at the toe or at the top of the slope. So sometimes you can't regrade your slope into something, a little gentler that wouldn't need stabilization. You've got to keep this steep slope in place because of existing infrastructure. And so you have things like a guardrail that's installed at the crest. You've got a fence at the toe. There's already roadways there, that sort of thing. So you can put the GeoWeb panels on these steep slopes without, interrupting the existing infrastructure. It's a great benefit when you do have these sort of tight spaces that you can't do, any sort of regrading activities. So this was another roadway. This was alongside of a road in the state of Ohio. This is a pretty common problem that's solved with the GeoWeb system. So erosion and washout of soil slopes onto road surfaces is a problem in a lot of locations, especially as you get more extreme rain events that you maybe weren't anticipating. So covering the slope with the GeoWeb system and then filling it in with topsoil allows for that vegetated slope without the concern of constantly having to replace the soil after storm events. So we do recommend some sort of surface protection, typically something like hydro seeding, or even using things like erosion control blankets. These can be used with the GeoWeb panels until that vegetation has a chance to grow, but then you're still going to get that nice green vegetated slope, and you don't have to worry about constantly coming back, cleaning up the road after erosion, anything like that. So embankments along roadways do have to deal with sheet flow runoff from your impervious road surfaces. So this was a slope for the Maryland State Highway Administration. So the sheet flow was actually causing sloughing of large sections in the upper topsoil layer, had deep rills and gullies, was preventing vegetation from forming, and was threatening to undermine the road itself. So the GeoWeb system was able to be placed over the already eroded soil, was able to hold everything in place and support that sheet flow runoff from the roadway. So no more gullies, and you finally were able to get full vegetation growth with some really deep roots that again help stabilize that soil. Road widening is also becoming a lot more common with state DOTs trying to find more road space without displacing any significant structures. Things like slopes and embankments are usually where that additional space can be found. This was a road widening project in New Hampshire. So the GeoWeb slope protection system allowed for steeper slopes to be created without erosion concerns. So the system can be installed quickly and then also vegetated really quickly so that there isn't a long construction time that may shut down those important roads. So ease and speed of construction are important features of the GeoWeb system. Everybody appreciates that sort of thing. So this was a hurricane erosion mitigation project. So this was a project down in South America. It was along the Zaramilla River between Peru and Ecuador. So the river is full of mangroves, and the existing currents within the river could easily pick up the loose sediments and soil, and they were eroding the banks and threatening infrastructure. Extreme El Nino events had caused catastrophic flooding in this region, and climate experts predict more severe storms coming off the Pacific in coming years. So they wanted some sort of permanent solution to help hold the river in its current location, even with these more extreme events that were happening. So during a brief dry spell, the riverbanks were actually cleared of vegetation and then regraded to allow for the installation of the GeoWeb slope protection system. The system provides excellent resistance to sheet flow, preventing that formation of rills and gullies, especially in areas of concentrated flow over erosive soils. In many areas of this project, protection of the slope surface allowed for the construction of steeper embankments with less horizontal footprint, thereby conserving valuable land space. Contractors were able to install about 2.5 million square feet, around 230,000 square meters of GeoWeb system along the compromised riverbank. Installation rates are actually pretty quick. Typically, you're going to see around 1,300 square feet per hour for a crew of 4, including your operator. So, give or take that a little bit, but you can move pretty quickly with this sort of thing. And at the Zaramilla project, the contractor further optimized installation rates by pre-staging the sections and assembling the system at the crest before expanding the panels down the slope face. So there's little tips and tricks that we can help you with if you are looking for a really fast installation. So the GeoWeb shoreline protection system ended up using a concrete infill for Zaramilla riverbank to protect against those future storm events. The GeoWeb system with concrete infill provides economical hard armor protection of slopes and channels when they're exposed to high flow velocities and high shear stresses. So the system has been proven to withstand sustained flow velocities of over 36 feet per second. It's over around 11 meters per second, and shear stresses of about 21 PSF. So this is going to outperform things like riprap, gabion baskets, and any other typical conventional hard armor strategies. So it's definitely the option to choose when you know you're going to have really extreme flow environments to deal with. So the quality, the surface finish, the thickness of the concrete, these can all be selected based on your project specific needs. The concrete filled GeoWeb system comprises flexible poured in place sections that are more economical than things like articulated concrete blocks, so ACB systems. And they don't actually require any specialized equipment to install. It is quick and easy, and it doesn't take any specialized training or anything. You're just really connecting all of the GeoWeb panels, expanding them down the slope, and pouring concrete directly into the GeoWeb panels. So it actually eliminates the need for things like form work because you're pouring into the panels. You don't need additional forms to hold the concrete in place, and you don't need things like rebar reinforcement or fiber reinforcement because the GeoWeb panels are acting as that internal reinforcement in place. So this whole project took about 4 months to install. Keep in mind it was around 2.5 million square feet. And so that included the excavation work prior to the placement of the GeoWeb system. So pretty quick overall. So again, that GeoWeb system becomes a flexible concrete slab that conforms to subgrade movements. It prevents uncontrolled cracking. It reduces the potential for piping and undermining of the system. So all good things when in these really wet environments that are going to see extreme flow events. And the work can also be integrated into the existing infrastructure in the area. The GeoWeb protection was placed up against bridge abutments, and it formed around culverts and drainage areas. So you don't need to redesign what's already in place. You can just work with roads and bridges and the landscape to create a solution that'll work. And with concrete, it's a permanent solution, even in these extreme weather regions. So the GeoWeb shoreline protection is performing to expectations and is going to provide some much needed protection to the Zaramila River and the communities that depend on it for when that next major storm hits, because we all know it's going to. Okay, so if global stability of your slope is a concern, or if you do have a very steep slope, think like 65 degrees or steeper, embankments really should be built as a retaining wall rather than just as surface protection. So the GeoWeb panels can be stacked vertically, just one on top of another to create a gravity retaining wall. And then you can also add GeoGrid tieback reinforcements if necessary. It's going to be pretty similar to your standard MSE block or gabion basket wall. So the walls can be filled in with topsoil in those front cells to create living green walls, and they can support vehicle or building loads above them. So like I said, there's two kind of different options for GeoWeb walls. You can have those gravity style walls. So you're going to basically build it up kind of as a triangle where you have the longer pieces on the bottom going up to something narrower at the top. Or you have GeoGrid reinforcement. This is where you have those GeoGrid tiebacks going back into your soil behind the wall, and it adds additional friction into the system to help hold everything in place. So we're not going to talk too much more about the specifics of how any of these things work. It's a topic all on its own, and we do have lots of information about this, either on our website or on our webinar dashboard, which you'll get information about at the end. So if you do have specific questions about how GeoWeb retaining walls work, please feel free to reach out. We have lots of information. We can answer any questions you might have. So seismic performance is definitely something that is a concern in certain areas of the world. Perhaps not in Kansas, but definitely on the California coast. So when you know that you have the potential for some pretty seismic activity in the area, going with the GeoWeb system is a great solution. So this GeoWeb retaining wall saw a major earthquake event, resulting in the sliding of the whole slope area. So you can see the GeoWeb wall system itself really didn't sustain any damage, but those concrete flumes that were in there were completely broken. So you can imagine how a rigid concrete MSE wall would have been damaged in the same way. But the flexible nature of the GeoWeb panels allowed for that earthquake movement to happen, that resettlement of the slope after everything, finally finished, and have it still be a strong retaining wall that's performing in the way that it needs to. And now you only have to replace these concrete flumes and not the entire retaining wall, or potentially even more if this could have failed catastrophically. Who knows what could have happened, below the wall. So this was an Ohio DOT project where a 20-foot high wall was actually constructed to keep the rock face from eroding further. So the GeoWeb system acts as a fascia against the rock wall that helps protect the road without taking up a lot of horizontal space. So this is a great option if you know that you have unstable rock walls or steep soil slopes in seismically prone areas. The GeoWeb wall can actually support and maintain that wall face during normal times. And then after a good ground shake, the GeoWeb wall will still be in place, and it can help prevent rock falls or landslides from compromising your roadways. So it's something to keep in mind if you know that you have roadways that could be totally covered and it would be devastating to have that road be closed. This is a great way to try and help prevent that. And the GeoWeb system works great along shorelines of stormwater channels as well. So placing the panels along a shoreline will help against erosion due to that water movement or wave action if you're on a coast. So this project was on a stormwater diversion channel that helps move hurricane waters. So during the hopefully infrequent hurricanes, the channel floods, and then it was severely eroding the channel slopes each time. And so they obviously wanted to stop that. They had some infrastructure on each side that they wanted to protect. So they wanted to stop that erosion within it and keep the channel within its banks. So the GeoWeb system, like I said, does work really great. Basically, you place the panels along a shoreline. It's going to help prevent that erosion due to water movement, and it can withstand direct or indirect wave action. So either directly up against the panels or just sort of as the wave actions are going, from down the channel way, as it's sideswiping the GeoWeb wall. Either way, it can help protect against that wave. And so this project, like I said, was hoping to keep the channel within its banks. So they were able to build up the GeoWeb wall. Because this was an area that was going to flood, they didn't bother trying to get nice, pretty vegetation to grow within the GeoWeb panels. So they filled it in with just their excavated material. So you can see it's a little bit of soil, a little bit of stone, whatever's they had on site. And that's perfectly fine, again, to use that sort of poor quality or mixed quality infill material. It's going to work just as well within the GeoWeb walls as anything else would. And so here you can see after everything was in place, so they were able to put a small slope above the wall to get to the grade that they needed to. The wall is now in place. It's going to hold that channel within its banks. It's not going to allow for further erosion. And when flooding does come in, the channel can rise, can go the whole height of that GeoWeb wall. And you're not going to have to worry about any failures or coming back at any point and trying to fix any damage, that sort of thing. So your stormwater can get where it needs to go, not compromise any surrounding infrastructure. So this was just a fun project I kind of want to highlight with the GeoWeb wall. This was actually avalanche protection. It was done in a small town in northern Iceland. So they needed a permanent avalanche protection wall, but they didn't want it to look too unnatural, bit of a compromise there. So a vegetated GeoWeb wall came in. So this wall was actually built from the ground up, completely freestanding, rather than integrating into an existing wall or slope. And so the wall had to be built so that it would protect the majority of the town from those anticipated avalanche in a couple different directions. So the GeoWeb wall actually curved and moved with the landscape. And the internal strength of the GeoWeb wall is enough to withstand that first huge impact of snow. And then the structure had to be high enough that it would allow for significant buildup during that avalanche event. And then access roads were built around and actually on top of the GeoWeb wall to make sure that the structure stayed clear of obstructions and it could be cleared up after that avalanche did occur. So here you can see it starting to grow, grass starting to get a little greener, look a little nicer. Eventually, all of that black plastic was hidden from view once the grass came in. And now the town has a permanent solution and protection against their own extreme weather challenge. So obviously not something that a lot of people have to worry about. Most of us are not, thankfully, in avalanche-prone areas, but it's definitely an extreme weather event that does have some pretty devastating effects that the GeoWeb system can help with. Okay, last topic, running a little bit behind. So this is using the GeoWeb system for stormwater control for mitigating flooding after storm events or even hurricanes. So the GeoWeb channel protection system is going to be really similar to the slope protection system. You can either cover an entire channel, so 2 side slopes and the channel bottom, or just a single embankment. And you can have either continuous or intermediate flow, low to high flow, and a variety of channel dimensions. So this system is going to be a lot more economical than the use of really large riprap stones or heavy baby and baskets. And again, you can choose your different infill materials to meet your channel needs. We did do some really extensive research with Colorado State University, Dr. Chris Thornton out there, to show how the vegetated GeoWeb system can perform in channel conditions compared to things like riprap. And basically, we determined that when paired with a good turf reinforcement mat, a TRM, the GeoWeb system can resist extremely high flows, allowing velocities of up to 30 feet per second. And so that's huge compared to just a typical vegetated channel, which, as you can see, is around 4 feet per second. So really big difference there. So the GeoWeb system does, again, work great along those shorelines of stormwater channels. We've talked about this before. So it's going to help prevent erosion due to the water movement, the wave action. And one of the great things is you can actually choose how much protection you need. So do you want it to go just down to the top of the water line? Do you need it to cover the channel bottom? Things like that. So this one actually decided to place the GeoWeb panels both above and below the average water line. And so the panels went below the water line to ensure that they didn't get lifted up. And they were filled in with stone below the water because obviously vegetation's not going to grow when it's permanently submerged. And then they were filled in with topsoil and vegetation above the water line to make it look like a nice clean channel. And that way it would still be able to support that water flow when flooding did occur, get up to that 30 feet per second that we just showed on the graph, and still look like a nice clean channel. So you can see that the vegetation has been established. You don't see the plastic anymore. The performance of the GeoWeb system is going to allow it to handle those fluctuations in water depth, and you're going to not have any erosion on those side slopes. Typically, we do recommend a soil and a grass type that's local to your area, maybe even using salvaged materials, just so it blends in a little nicer. But here you can now walk along the shoreline. You don't have to worry about sinking in. You don't have to worry about erosion. It's all good and protected. You can also fill in with stone or concrete. As we've seen in the past, stone infill might be appropriate if you're in an arid environment or otherwise don't believe that vegetation is going to grow in your area. Like I said, water does not grow in, when permanently submerged. So if you do have that consistent water level, you might need to do stone below and vegetation above. And then concrete is going to be the choice if you know you have really high flows. There's no restrictions in terms of flow velocity or shear stresses when your concrete infill is used. So steep channels or high flows after storm events, these are places where concrete infill might be helpful. You can even include things like baffles or energy dissipators within concrete filled GeoWeb channels. So if you know that you need to slow down your water or if you need to have it directed off in some way, concrete might be the way to go. So this was a stormwater channel down in Florida showing how the GeoWeb retaining wall system can be used. So the stacked system is really great in urban areas where you don't have room for shallow side slopes or you don't have room for setbacks. And then you can, again, still use vegetation above the water line and stone below. You can also be used in conjunction with riprap, if you still need that due to local regulations or anything like that. So this was a culvert outflow in Milwaukee, Wisconsin. So a strong surface protection, in this case, they used a core fabric, were able to help withstand those really high flows. And again, this is intended for short duration events rather than continuous flow. And then you can also go around existing infrastructure, such as those culvert outflow pipes. You could also include things such as sonotubes if necessary. And we also often hear from contractors about how easy it is to install the GeoWeb system, even if they've never worked with it before. And we do have installation guides and tutorial videos on our website, as well as providing on-site or personalized virtual assistance when required. Okay, so I'm out of time, but here's my summary. So every project is different, but the GeoWeb system is going to have a solution that's right for you. The GeoWeb system can be added to road projects, can be used on slopes or in channels, can even build green retaining walls. So whatever your stormwater challenge, if you know that you have extreme weather events that you're going to have to deal with, if you just want to have that little bit of extra protection, the GeoWeb system is going to be a great solution to make sure that you have a long-lasting, permanent, in-place solution for whatever your needs for all of your project-specific requirements. So please, if you do have any questions, if you have any challenging projects that are sitting on your desk that you've been looking for a solution for, feel free to reach out. We would love to discuss it with you. And so I've mentioned it a couple of times, our free project design evaluations. It's part of our complete system solution. So myself and the rest of the engineering team, we work closely with landscape designers, engineers, contractors, owners, whoever. And we do offer that free project evaluation service. Basically, you can go onto our website. We have a little button at the top where you can fill out all of this information. You can include documents such as geotechnical reports, project site pictures, other info like that. Comes directly to our engineering team. And then we provide our recommendation for what GeoWeb system is going to be the most appropriate for your site. We're going to include anchorage recommendations if we think any sort of extra geotextiles might be appropriate. We're going to give you details that can be included into your plan sets, things like that. So we're going to work with you to get you the best design for your project. And so we do deliver quality, and we have over 40 years of experience guaranteeing each shipment is going to meet or exceed our specifications, so you can deliver with certainty and build with materials that you can trust. We have no disclaimers. We've got no fine print. What we say is what you're going to get. All the good stuff. Okay, so thank you for sticking with me. I know I went a little long today. Just a touch of housekeeping. We are making it faster and easier for you to obtain your PDH certificates. So with your webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars that you've completed. Your webinar dashboard is going to keep a record of what webinars you've completed along with your PDH credits. So in 2 to 3 days, you will be getting an email from Presto Geosystems with more information about accessing your webinar dashboard and some other helpful resources based on what we've talked about today. So look for that by the end of the week from Presto Geosystems. If you attended live today, thank you, and you're automatically going to receive a PDH certificate for attending live. You're going to get that within 24 hours from GoToWebinar. That one's not going to come from Presto Geosystems. It's going to come from GoToWebinar. It's going to show you how you can download your PDH certificate. So check your email, check your spam folder if you haven't seen it in about a day. Okay, so I know I've gone a little over today, so if you do have to get off, I appreciate you taking your time. I'm going to get into a Q&A session. Some good questions have come in through this the questions tab. Those questions are going to be recorded. So if you have to get off today and you want to come back onto your webinar dashboard, you can get a copy of this presentation, you can listen to the Q&A, and you can make sure you have all of my good contact information if you do have any questions that you want to reach out about. Okay, so let's get into some of the questions people have put in here. So one of the first ones was, where are the products manufactured and do they meet Buy America clauses? So yes, all of our products are made either in Wisconsin or in Illinois. So they do meet Buy America recommendations. So if you are working with, a federally funded project or anything that has those Buy America requirements, all of our products meet those requirements. And we would love to help you get our products spec'd into your project. So great question. Some questions about, let's see, how do you choose what fabric you might put underneath your GeoWeb system? So I mentioned it sort of briefly a couple times in the case studies and sort of at the beginning. You might end up choosing a geotextile fabric to put underneath your GeoWeb system. And so I'll start by saying it's not always required. It's definitely something that would be an addition to the system. You wouldn't necessarily need it if you are building a soil slope on, or putting soil protection on a soil slope. In that case, you wouldn't want a geotextile because you want that root zone to really get down into your slope. You don't want anything to disturb that. You potentially would want a geotextile when you're going through, like, say, a wetland environment in a roadway application. And this would be helpful because it would provide some additional strength. It would provide a little bit of filtration and help allow that water movement, but it would also help confine the stone within your GeoWeb panels so that it doesn't migrate out through the bottom of the system. So that could be an area where you would want, say, a woven geotextile. So it is pretty project dependent. There is, again, no one right answer. So that's something that I would encourage you to reach out to either someone here at Presto Geosystems or your local distributor who we could get you in contact with as to say what geotextile is recommended, whether one is necessary at all, that sort of thing. It is going to be, as I said, pretty project dependent, but typically you're going to see either a woven or non-woven geotextile in that type of application. Okay, let's see, some other questions. So when you presented the hurricane scenario, how will the GeoCell work in low-lying areas with a high water table or fluctuating water table? So that's a great question. So in areas that have the potential to flood over the top of where the GeoWeb system might be, how does that work? And the answer is really that the GeoWeb system is going to stay in place during flood events, even if it is fully submerged within that flood. So if you're on a slope, say you're on one of those channel embankments that is trying to corral hurricane floodwater, the floodwater can rise up over the embankment. The channel side slopes typically would erode, but when you have the GeoWeb system in place, you're going to help prevent that erosion. The GeoWeb panels themselves, in that case, are going to be held in place through that anchorage system, whether it's the stakes or the tendon system that we talked about. That's going to hold the GeoWeb panels in place on a slope. If you were to have a GeoWeb roadway and have a severe flooding event that would potentially even overtop the GeoWeb road during that event, what's actually going to hold it in place is typically gravity weight, especially if you have a stone infill. The stone's still going to be confined within the GeoWeb panels, even when it's submerged. So that's going to help hold it in place. The GeoWeb panels don't float or anything, so they're not going to try and rise up to the top of the flooding area. So it's really going to just sort of stay in place, and then once those floodwaters recede, the GeoWeb road will still be in place and be usable. If you are concerned about this, if you know that it's something that has happened or has the potential to happen on your site, you can add a little bit of anchorage even to the GeoWeb on a flat area where typically you might not need it. You could add those stakes or a tendon system as additional protection to help hold it down. But in general, it's going to stay in place during those flood events. So even with rising and falling water levels, water movement due to flow, anything like that, the GeoWeb panels are intended and are going to stay in place. So some other questions here. The roughness is going to be significantly lower than riprap in a channel and can reduce the channel area. Okay, sorry, I was trying to read through the question. So basically, yeah, when you have a topsoil filled geoweb channel as opposed to like a large riprap channel, that is going to obviously then change basically the Manning's roughness coefficient in your channel calculations. So that can help you potentially, reduce your channel area, reduce your channel footprint because you have, better water flow through the area as compared to riprap. That's something that we have done and can help you determine if you're trying to figure out, I want to build or rebuild a channel, but I want it, footprint to be a little lower, or I want to have, those retaining walls as my side slopes to have, a deeper channel without a larger footprint, something like that. So that's definitely a great application of the GeoWeb system, is to try and rebuild channels in a smaller footprint that you wouldn't necessarily be able to achieve with conventional methods. Okay, I have gone significantly over today, so I thank everyone for sticking with me. I hope that you have learned something, or that this maybe just sits in the back of your brain for a little bit, and when you do come across a challenging project, or that you think about some extreme weather events that might affect you in the future, you think of the GeoWeb system and how we can help. And I really urge you to reach out to myself or through our website. You'll get a couple very good qualified people. We'd love to talk to you about any projects that you might be working on now or in the future. And I hope you all have a really good day, and we hear from you soon. Bye.